Just.
Meat science, quality control, and industrial pilot studies to scale up food processes. Dr. Modi has more than 100 publications, including presentation in national, international reputed journals. He developed 33 technologies listed with 67 products processed, mostly licensed to more than 130 entrepreneurs for commercialization. He guided national and international PhD students, postgraduate research or project fellows or project assistants under various national or international fellowship or funded projects in the area of food technologies, food science and nutrition, biotechnologies and microbiology. Thank you, sir, for being here. I would like to request you to present your lecture about meat processing technology. Over to you, sir. Hello.
Sir, you are muted, sir.
Am I audible?
Yes, sir, you are audible.
Okay. So today is in the workshop, the subject what it is picked up, it is the meat processing technology. After that meat processing technology, I have mentioned a few words that subject of concern. That is a very relevant to our the present processing industry concern. See, meat in our country, it is not so well organized sector. That's why this needs a little more attention than the processing of fruits or vegetable or any other food products, technology or processing. So that's why we need a little more attention in the meat processing. So just to understand the subject about the meat processing, where we are lacking basic concepts or basic things that needs to be addressed here, and it needs a very high alert in for the industry. So let us first try to understand the status of meat industry in our country. See, this workshop specifically, it is focused on the technologies for increasing the shelf life of perishable foods. So among the perishable food, meat is at the top. Meat and dairy industry is the top because they have very, very limited shelf life of the product. So to understand this, how we can overcome this problem, let us first understand about the product, raw material itself, from where it comes. So the meat processing industry, that what it starts from the abattoir. Abattoir is a place where we slaughter the animal. What is the status of abattoir in our country? That is in to look at this abattoir or where the meat is processed or slaughtered. The first step it is of the industry is that the the abattoir. What type of abattoir we have? There are private abattoir, traditional abattoir, some training abattoir, and of course modern abattoir where the production of meat it is in a domestic or export purpose. It is in a means it is going on. But these are very limited in our country. Mostly it is a traditional way of abattoirs at a corporation level, and that is the domestic consumption of the meat. In our country, that processed meat share is very, again, it is a just negligible. We all consume the fresh meat only. Though now in the last few years, few industries have come up as the packed meat products or a fresh meat marketing and all. So, so to look at this scenario, first what we have to understand about the status of traditional abattoir. As I said that the meat production in our country is dominated by the traditional abattoirs or traditional method of slaughtering. So where we stand, so the drawbacks of these abattoir, I'll share you a few pics of the abattoir. There are the inhumane practice, means the animals are not well treated, slaughtered in open ground slaughter or on the floor, which of course the deteriorates the quality of raw material itself. That is the source of highly infection in the or contamination of the meat. Inadequate ante-mortem or post-mortem inspection. While slaughtering the animal, we don't care about the animal, whether the animal is fit for slaughter or not. Means it may be a as per the guidelines, the animals are not supposed to slaughter at a particular stage or under the conditions. Like animal if is sick or animal is with not in a have traveled for a long time, immediately we cannot slaughter. So these are some scientific points are there where we are not giving any stress for production of the quality of the meat. And then of course that is the unskilled operators. They do not know how to operate the means the slaughtering process. They do not know how to handle the dressed meat. Poor maintenance. Abattoirs, the traditional, that is, are very poorly maintained. Not adequate water, no ventilation, no disposal of the waste material, and no basic facility for slaughtering of the animal in the traditional abattoir. And then that comes under the lack of basic facility. As I said, water or disposable, the two basic things are required for this. Adequate clean water and disposal of the waste should be in a very systematic way. Then only we can think about the production of a quality meat. Now look at the statistics. If we see that where is the world and where is the India. So we are the meat producer, that is 8.14 or million tons only meat, as whereas the world production is 337 million tons. So the meat production we are very just negligible from the world. Our main production of the meat is only black or means our buffalo meat, which we are exporting to the other countries. Rest of the meat, it is all fresh meat, what it is consumed in our traditional way. So now how to make it as a factory, this abattoir, how we should deal with it. So we should, there as any factory or any, there are the raw material handling, disposal and byproducts and then finished product. And similarly here in abattoir, we have to look at the three angles: waste disposal, byproducts, utilization of byproducts very effectively. That adds to your bringing down the cost of production as well as adds to the profit to the company. That we cannot neglect. Then final, of course, that the objective is to produce a clean and quality meat. So these all three factors we have to stress for the meat industry. So looking at this scenario, that what is the requirement for the production of a quality meat, we have to establish the modern abattoir. As per the looking at the figure, means the requirement of the country, that a quality meat, we should stress on the development of the modern abattoir, where we can produce the hygiene meat production, effective recovery and utilization of byproducts. Byproducts are here especially is the skin, animal skin. It is as adds to the cost of the company to the total meat. It is a valuable products. Then hide, hooves and blood and so many other byproducts are there that could be utilized in a very effective way for the production of the as a whole industry. Then of course waste disposal is a very important factor just to control the pollution and other the contamination. Similarly, that pollution control and waste disposal, it is interlinked. So we should have a very effective way for the waste disposal in the abattoir. So now for the hygiene meat production, what type of the additional things what we need? What we say that good manufacturing practice, it is a very common for any kind of the industry. Then critical hazard analytical critical analysis point, where we can access the quality and can see the control, and we can judge that these are the few points where we have to stress for the production of the quality meat, or the free from the contamination and all. So these are the few steps. Next, the water spray, hot or cold. These are the required as a basic requirement for the cleaning of meat during the slaughtering. Acid dip or spray, that is again one process for this, for decontamination, ionization, radiation. It is the last step, of course, but it is permit. It is if the country permits, that steps also can be looked out or during the production of the meat. So now the modern processing, that the what it includes, as I said, that the hygiene means the processing on over rail system. In the next few pics, I'll just try to clear how it is done. See that in the traditional abattoir, the butchers or the processor, they slaughter the animal on the ground floor, on the floor where all sorts of the contamination comes in contact with the meat. Whereas in on rail system, we can avoid any further animal to animal contamination. Careful removal of skin and viscera. If viscera during the processing, if it spills on the carcass, it is a heavy source of the contamination. Removal of skin, that is again, skin is a source of the contamination. That should not come in contact with the meat during the evisceration or during the deskinning of the carcass. Includes better cleanup operations, washing the carcass with spray water, sterilization of slaughter paraphernalia, where knife and other things which is used, that should be sterilized frequently while using into the abattoir. Scientific method for handling meat. Now this is the very important, that we have to give a proper treatment, that is the what we call as a pre-Riger or Riger set, means the meat where the pH is controlled. And so that means that before slaughtering only we have to give a complete technological aspects of the animal, where we could get the maximum glycogen content, so that the rigor mortis sets in a very proper way, and we get a proper pH, which helps in tenderization as well as in extending the shelf life. That is the first parameter where we have to deal in the processing of meat, the rigor mortis. That is very, very important, that animal should be slaughtered in such a way that the stored glycogen should be maximum, so that we can get a proper pH during rigor mortis. Application of hazard analytical critical control, that is very important. Sanitary measures, microbiological quality, of course, that we have to look into in each product. Now that the production, that is the pre-requirements of any kind of the thing. The meat production in the abattoir, how we produce the quality meat. I think my slides are stuck up.
Yes, sir.
sir. Yes, sir.
Yeah, just give a minute.
No problem, sir. Please take your time, sir.
Yeah.
Yeah, fine, sir.
Oh, screen sharing has stopped.
Yes, sir. Yes.
What happened?
Maybe, sir, you have closed the window or something.
1 minute. Slide is visible?
No, sir. Not yet, sir.
Not yet.
You can close screen, sir, and start sharing again, sir.
Again, I think I have
Yes.
to do it
Yes, sir.
again.
Yes, sir. Now it's visible.
Visible?
Yes, sir. Yes, sir. Perfect, sir.
Yeah, I was here, I think. Meat production.
Yes, sir.
Okay. Now, in the meat production, that depends the type of the animal what we use for the slaughtering. So the basic thing that actually that in our country, meat, it is a byproduct. Our main product is the milk or wool from the animals. If I just give example of sheep, there are the few sheep, varieties of the or breeds of the sheep which is available in our country. Some are the meat variety where we get the yield of the meat, it is the maximum. And whereas the other breeds where we rear the animal for wool purpose or for milk purpose. So ultimately that goal is when the animal productive period, especially for the milk, when it is over, then only we slaughter the meat, slaughter the animal. At this stage, meat becomes the tough, because that the quality of the meat, that because of the age of the animal, that starts becoming the toughening of the muscles, and then we get a poor quality of meat. So first step is that we should rear the animal for meat purpose. So we have to get ready with the meat breeds which gives you a quality and the maximum yield of the meat. So this is the few examples here for all types of the animal where we slaughter these for the purpose of this. Now, these are the few the layer and broilers, of course, and then the other source of the meat where duck, country hag, rabbit, and quail, that we are there. So this is the piggery source. Now, type of the meat, what type of the animal we are slaughtering? Stray animals. This type of the animal we slaughter as a local means marketing of the meat. So we cannot expect a quality of meat from such animals because their productive period of the age factor that is over. So we get a tough meat. These are the animals, large animals or cattle, when they are plowing field or everything, it is over, time period it is over, bilching period is over, then we slaughter the animal. So under these conditions, we don't get the meat, a quality meat. So we have to go with when our objective is production of meat, means we should have a proper breed at proper age and maintenance of the animal. For that purpose, then only we'll get a proper quality of meat. Now comes the scientific technique, how we should slaughter the animal. First, I'm giving you the details of the scientific methods, how we should deal with the animal, or we should slaughter the animal. First step, it is where the veterinarian doctor examine the animal, that he is or animal is fit for the slaughter purpose. Fit for slaughter purpose means the animal should be at proper age, that they identify through the number of teeth available, then temperature of the animal, whether animal is not sick, and then third thing, that any bruise on the surface, because animals are aggressive in nature at some time, so they fight, and then there may be some bruising or skin means disease or something, it will be there which is appears on the surface of the animal. So that contamination, that will become a contamination source of the animal. That may be from outside or from inside also, that some bacteria or some kind of the disease may be having. So those things, after inspection, then we put the animal as a training abattoir, they put on the cradle, not on the floor, on the cradle, and then we stun the animal with a mild volt of 70 volt. So animal becomes the conscious. This step is very, very important, because the animal should, as a scientific technique, animal should not struggle during the slaughter, because if animal struggles, then the entire energy is exhausted, and energy exhausted means the stored glycogen content, it is not available with the animal, and that glycogen, which during the glycolysis cycle it converts into the lactic acid, which helps in the product, the reducing the pH, and that pH helps into the control of your the tenderization and the shelf life of the bacteria, shelf life of the meat. So this makes the animal unconscious with this a very mild current becomes that is 70 volt for few seconds, and then we start cutting the animal in a traditional way. Again, it looks like a traditional, but on the a cradle. So then once it is done, then we tie the esophagus, the intestinal link total, so that the viscera should not come out from the animal, or the fecal matter should not come on the carcass. Now, now the deskinning, the first picture, that deskinning, that is again everything it is done on the cradle for the in the beginning. Later on, we hang on the rail. See, that is the rail system. It is there where the on the hanging system everything it is removed, and then the all the steps, if you see that entire viscera it is removed, and then in the last but one, that where the veterinarian doctor examines the post-mortem inspection of the animal. So that is the pluck, and then first we see the lymph node, that should be a very smooth from the neck portion. When we see the animals, that node should be a uniform, soft and uniform color. So that gives the first indication that animal is healthy. Second, we cut the liver and examine any abnormality or patches of the different colors, especially with the white or dark brown color patches. If it is there in the liver, it means animal is suffering from some disease. So it should be a uniform color and smooth in texture. Then finally, of course, washing with a spray water from top to bottom. So whatever the some contamination, if it is there, that should be washed away. So this contamination and the washing, that could be even with the hot water, a mild hot water with the 60 or 70 degrees of this temperature water, a fraction of seconds only, just the hot water come in contact with the surface. The purpose here too with the hot water washing of the animal means that is first thing, that a little contamination, it controls the contamination, of course. Second thing, that it dries the skin very fast. That is very important. If the surface is dry, then the spreading of the bacteria or growing of the bacteria, it is to certain extent it is controlled as compared with the wet skin of the animal, because it is loaded with your biological material. So bacteria growth is very fast, and if we just give a surface wash with the hot water, to certain extent it helps in extending the shelf life of this. Similar process with this was for the sheep or goat, and this is for a batch process for the poultry. How we do it, the same process we follow. Steps are different because of the nature of the bird or carcass shape, size and all. So again, it is this one. Now come to the local abattoir. Meat production at local operations slaughterhouse. How we deal with our meat in our country. It is a true picture. It is not a means from any source. It is just from the one local abattoir from the city corporation. The animals are dragged from kilometers, not 1 or 2, even sometimes even 5 or 10 kilometers. Farmer midnight, they start dragging the animal to the abattoir like by walk only. So under that process, the morning when they reach to the abattoir, 5 or 6 o'clock morning, 4 o'clock, the animal is exhausted, but they don't give any rest or water to the animal. And under that condition, as I said, the glycogen content is not there. Second, in the lorry, you see that one, as per the guidelines, the lorry, the animal should have a specific area for the transportation, but our transportation system is so bad, they stuff the lorry just like a vegetable only, overloaded, and the animals become suffocated. They fight each other inside with the available space, and that again it gives a total exhaust to the system of the animal. They put into the lares just to see the floor condition of the lares where the store we keep our animals, and then when we see these animals means under this condition, and then again see everybody is frightened. We can see that yes, death is there in front of me. So the same thing it is with the animal. because that they heard the screaming voice of the animal from the inside. They can see that now. So they are not willing to go inside the avatar. They are dragging the butchers or the workers. They drag the animal physically. Under that, the so again my point is that they exhaust their energy. ATP content is lost totally. Glycogen is not there stored. Again, that we get a poor quality of meat. This is the avatar saying inside. You just look at the floor, how the animals are dying there. And this is not for a meat purpose. It is just like a, जिसको हम बोलते हैं ना butcher खाना है, but the picture it is means we don't means that doesn't look like a meat production center. See, this is the way how the animals are treated inside the local avatar. Look, everything it is done on the floor. So one animal's fecal material is contaminating the meat to other, and this is the very pathetic bad condition. Look at this child labor and the dress of the butcher inside who is working in the, and the person who is slaughtering, he is not means looking after his health. He has put the knife inside his mouth because his both hands are engaged in dressing the carcass. So carcass, if it is contaminated, it is a source of disease that may transmit to the man. So this is the status. See, washing the in one pool of water, number of the carcasses, it is they don't have any spray system and all. Just they dip the carcass in the in a tub, which is already highly contaminated with one other carcass. Same place they wash the skin, same place they wash the carcass, and same place they wash the intestine. This stomach, liver, gizzard, everything they wash in the same cut. How it is the pathetic condition. Look at the waste disposal system in the avatar. Let us not stay more on these slides. And finally, just hang the carcass and we put the seal that meat is produced in a local avatar and it is ready for marketing. This is the outside of the avatar where how means the bad conditions we can see. So under these conditions, how we can expect a quality of meat? How we can expect where have a good shelf life of the meat? It is highly contaminated. It is thanks to our processing technique at domestic level that we cook the meat in such a way that everything it is taken care. But have you given a thought that okay, cooking takes care, but once this type of the meat, when it comes to our kitchen, that meat contaminates to your utensil, washer, knives and plank. So that will give a additional contamination to your kitchen. Of course, of that meat, whatever the muscle contamination is there, that is taken care during the cooking. But what happened to the pre-contamination of other things in there? So this is the way how to. So now, after processing, let me share with you a few things that how we can extend the shelf life, how we can control to certain extent the contamination, or so that it should not further deteriorate the quality of the meat. So one part of this, it is the handling, and then of course second comes to the packaging, then of course it is the market chain, cold chain system, and then of course that we can look at certain the meat products processing. When we talk about the meat processing technology, the product also we should not forget it. That is the one part of your meat industry. That is the fresh meat production, then of course the quality product production. So let me just share with you that a little bit about the fresh meat, extending the shelf life of the fresh meat. First thing, it is the chilling. As a food processing principle, we know that at the lower temperature bacteria doesn't grow. Means the rate of growth of the bacteria, it slows down. It grows of course, but slows down. So we can control damage. Immediate after slaughter, that chilling becomes a very important. Then cooling the meat to about 15 degrees centigrade allowed to onset rigor mortis to prevent cold shortening. So at this temperature, if we, because inside that body heat, what we call the body heat or rigor mortis to complete, that the glycogen, stored glycogen with the available ATP and all, that converts into the lactic acid, set rigor mortis, that tenderizes the meat. I'll explain a little bit more to this aspect in the next few slides, how we can set the rigor mortis and where we should target it. and then transport and stored at 2 to 4 degrees centigrade for a local marketing, a cold chain system. Next step comes that if we want to have a better shelf life, then of course that comes the freezing, effective method of storage of meat, and that is the temperature we need. It is -18. Actually, freezing we should do at -40 and stored at -18. That is the prerequisition of the freezing of the meat or method of freezing. That depends upon the type of the freezing method. What that again depends upon the technological aspects and the type of the meat. So that method we have to select accordingly. So these are the few methods available. Blast freezing, it is mostly for the whole carcass with bone and all. That is the contact plate freezer, the individual quick freezing, cryogenic agents and all. So these are the few methods available for freezing. That all depends upon the source of the facility or availability of the facility and the type of the meat, what type of the, and the target of the storage of the life of the meat, what we want exactly, and for how long we want to store. So this all depends upon the freezing method and all. And of course packaging, of course, that the type of the packaging what we are accepting for freezing. So that all depends upon this. In contact plate freezing, the type of packaging is different, and in the case of the blast freezing or whole carcass with the packaging, it is a different. So now very, very critical thing it is that where we again lose the track, the fluctuation in the temperature. The frozen storage should be at -18. The fluctuation happens due to the power failure or defective system of the freezing. Anything that means if it is a frequently fluctuation in the temperature, thaw freeze or thaw freeze, that damages the texture of the meat. So that should not happen. Or freeze burn if it is not properly packed storage during storage, so that due to the sublimation that the surface becomes dry, that moisture will evaporate directly, and that gives you a very dry surface of the meat, and that what we call it is a freeze burn. Similarly, thawing, reverse freezing, surface spoilage fast, very fast. So when after frozen, when as a commercial activity, when we thaw the meat, it is a very serious step to look into that, because we cannot keep the meat for a long time for thawing. It is a very slow process again. If we leave the meat at the room temperature for a long time, the surface temperature is equivalent to the room temperature, and which will give you a chance of the bacterial growth on the surface. So surface spoilage becomes very fast. So thawing is equally important in that the commercial. And then of course that quality. What aspects we look into the quality in the technology part of this meat? So first thing comes that the see, as a meat or any food, how we like it. Two factors are very, very important for the sensorily acceptability. Any food, if you just go, the tenderness and of course that flavor of the part. So especially we look at the meat, we prefer the meat or we enjoy the meat just because of its textural part. So how we can control the tenderness or texture part of the meat. So first thing, it is of course the breed. As I said, the particular breed influences of the growth of promoting hormones and the minor influences on the tender. See, certain industries, just to grow the muscle, we use the hormones. That also affects to the texture of the meat. So as a natural system, no, we should not use any kind of the growth promoting hormone. That of course that is against the law, number one, and of course it affects to the quality of meat as a tenderness of the meat. So that where we should target the variability within the breed. One breed gives you a tender meat, another gives you a no. Just like in the poultry, the layer meat has a different texture and broiler have a different texture, and then country hen, it is a different texture, and then game birds meat, it is a different texture. So that's why means the breed has also an important role in influencing the tenderness of and the breed differences in the pH of the muscle. That is the natural pH of the muscle. It also affects then heritability of the, of course, that is all related to the genetics of the breed of the animal. Now muscle proteins may be Now look at the scientific part. Now, of course, okay, as a commercial, we cannot depend on a particular breed of the animal. That is a one. We know that this particular breed gives you a quality of meat. But now we have to control as a scientific part that how we can control the texture of all the type of the raw material available or a meat breed it is available. So now the muscle protein, which is the sarcoplasmic protein and myofibrillary and connective tissue, that is the collagen of basically. So there actually these proteins, if we means control during the rigor mortis and the processing steps, their denaturation and all, so we can get a quality tenderness in the meat. So the sarcoplasmic proteins, which is the marginally affects to the texture of the quality. The major part is the myofibrillar protein, which myosin and actin and the connective tissue, which they are the major part which controls your tenderness. So our target again, that myosin and actin or myofibrillar protein and connective target is this, how to make them a tenderizable. So variation in meat tenders are directly the result of variation in the state of these protein fractions, especially actin and myosin and the connective tissue, and contributor by this as a actomyosin, that this look at this picture, that how the actin and myosin they are working in the system in a muscle. During the muscle contraction in the live conditions, this actin and myosin moiety, they keep on means contracting and relaxing as a regular muscle activity or our body activity. But after death of the animal, this contraction, because of the availability of your ATP, means energy is not available now for this contraction and relaxation of the actin and myosin, that stops. And what happened? They lock. So they give you a ectomyosin, locking of actin and myosin in the next picture, where both the moiety are now locked. So this is without ATP because energy is not available to this. And so that is called that rigor mortis. Now, what happened during rigor mortis? This ectomyosin, when your sufficient glycogen is there, you get a lower pH 5.4 or 5.5. At that pH, this ectomyosin breaks. Now muscle pH is around 6.6 to 7. Under that, it is means contraction or relaxation is going on. But slowly when this stops, and parallelly if you get the proper pH, and this ectomyosin breaks at lower pH, 5.4 or 5.5 pH. So again it becomes separate and your meat is now tender. So it is no more tough. But this situation, if pH doesn't get, then this ectomyosin remains in the muscle, it gives the toughness in the meat. This is the target what we should get to produce the quality meat. Now, how we can tenderize? This is the natural way of the technique which is used in abattoir for a proper rigor set to get the tenderization. Now, after that, how we can get that individual protein muscle raw, means there where we can use a kind of the acid or marination or heat process to tenderize all these the individual protein molecules. How we can do or means tenderize the meat so that the natural structure of the protein changes and the process of breaking or unwinding and coagulation, what we call the denaturation, that connective tissue protein. So if this sequence of the means the breaking or unwinding of the protein, if we control after post-mortem or after rigor mortis, of course we fail to get the pH, but again we have another artificial methods of the tenderizing the meat, where we can do this muscle fiber with the coiled protein that is in the natural muscle first protein. But when we when denaturation of protein happens by one or other method, this coils opens. This could be because of any reasons that what we apply for that, or a kind of a marination. Again, it is a factor of your pH. We are reducing this uncoiled, and that becomes a tender. So the protein molecules, they separate each other, and that gives you this one tenderness in the meat. Now collagen and actomycin, as I said, are the major protein which affects the texture of the cooked meat. With increasing temperature, the sequence of change of collagen and actomycin. See, collagen first, when we apply the heat, it contracts, then denature, and still if we give a higher temperature of the cooking, we get a solubilization due to the gelatinization of the collagen protein. So under this situation, our meat is very tender. Similarly, the actomycin denaturation and reduction. So at this stage, when we apply a pH or a heat system also, this actomycin also denatures. Under that result, the reduction in water holding capacity. So releases the water of this particular protein in that system. So now disintegration at high temperature, this water holding capacity means this water is available for cooking purpose. So your meat will not dry, further water will not come out from the other protein part, and that gives that water will help in increasing the temperature in the system and gives you the tenderness and the uncoiling of the protein, that collagen, that what I said, that solubilization. At that stage, this is the very helpful. Now, the direct relation of the temperature and the water content of the meat, that helps in the tenderization of meat. That, as I said, that now medium of cooking, that medium may be water, maybe oil, or maybe some solution, that also helps in the tenderization, because various factors helps in the which controls the temperature. If oil is there, high temperature is there, and then conduction or cooking, that I'll just give you example of tandoor, how it helps in tenderizing the meat. So then ingredient formulation, of course, that help, that is just kind of a marination. I'll give you one example. And of course, the processing method, what type of the method we are using, as a canning or as a baking, that all is a play game of the temperature and water content of your meat. So as I said, that marination is done, what type of the marination, that enzymes or papaya fruits, or all those, these are the sources where we get this one. The again, that the example of heating, the type of the heat and the rate of the temperature of heat and the intensity. If I just give you an example, just let us take example of our tandoori chicken, which is very most popular product in our traditional system. A tandoori chicken, why this particular, it is so juicy and means tender compared to any other product. See, where we do the first, it is the we do the marination, helps that the salt and the means or pH by lime juice and other spices, that helps in the reduction or actomycin or actin or myosin that break down and denatures, and the water holding affects to the water holding capacity and releases the water from the muscle. Now, when we put it at a very high temperature in the tandoor, what happens? So a very fast heat penetration system with the conduction system, with the superheated walls of the tandoor, which from all direction high temperature when we provide, what happens? The surface of your meat, it becomes very high temperature, and that migrates with the available water content. With the marination, we have given that the water holding capacity, water is already released, freely available in the muscle. That water becomes heated and evaporates. With that heat, inside muscle is cooked very fast, and surface of this particular thing, that evaporates that water surface and becomes a very crispy layer. That is the reason that particular kind of the texture is available with the tandoor, in a very high temperature cooking, with that goes up to 350 degrees centigrade temperature, even sometime more. So that is the reason why this particular heat gives you a particular texture in the product. That's why I said that the water content and the temperature is the main responsible for the quality meat. Just I have given a picture of the tandoor, how it works. Now this is the final product. Similar kind of the other products are there, which also helps in the basic purpose is here a very crucial role of the marination. How to reduce means increase the water holding capacity of the system, which we should not lose it. In the high temperature, when we heat it, the surface, I said, at it is slightly means denature, it shrinks and close the pores of the surface. So water doesn't come out from the surface in the high temperature. that the skin, it is denatured totally, that whatever water is there in the muscle, it is locked, and with that water only inside it is cooked, and your meat is very tender. So that applies the principle of your marination, type of the marination, what type of the marination we use it to make it tender, and of course it adds to the flavor and texture. Uh, So this is a very commercial way of tenderizing the meat, and just to mince it, the texture means whole structure is means disturbed, and so that we get a different type of the texture. Another one, a very recent technique, it is there, that the placing the carcass in a water and then setting of the controlled explosion in the water means to tenderize the carcass. The supersonic shows means the waves instantly fracture the muscle fiber, that the bombardment of the sonic this one, so that means fractures the fiber. As I said, that unfold of the during the marination or with the heat, unfolding of the biofibrillar protein or the connective tissue protein during this, a similar kind of thing here, without increasing the temperature, by supersonic waves we hit the muscle, and that fractures the muscle, and that of course then it results into the tenderization of the meat. Now, as in the beginning I said, the two steps are very important in our food processing and the meat processing. Why we eat meat? Because of texture, and second is of course the taste. In the taste, the flavor is the most prominent part of this one. How the flavor is generated in the meat? Again, we have to come to our rigor mortis stage. See, the integral part of diet, not only source of the good protein, but also of the sensory properties. And all meat lovers, they know the properties of the meat, why they like it, that what it gives a sensory properties in the meat. That most effective tool of sensory is the flavor, where aroma and taste we consider it. And this aroma and meat that is generated in the cooked meat. In raw meat, it is a raw flavor, like a just meat, or means a raw blood type of the, but when we cook it, and then we get the flavor. And how this flavor is generated, how we can control this flavor. So these are the factors. Again, it go back to the production line only, the quality of meat, that is during the slaughtering, how much we are able to store our ATP or IMP. That I'll give you before that, the few more things which especially related to the aroma. Animal species, breed, sex, age, feed also affects to the flavor or the aroma in the meat. The slaughter condition, processing method, all are the basic things which affects to the flavor of the meat. Now, as I said, the ATP, our energy source of the meat, if it is well stored, it is there. So during that the whole process, what happens? The ATP breaks down to 5 inosine monophosphate, inosine and hypoxanthine, and then that gives you a ribose moiety. And other side, amino acid, that of course that we know that the free amino acid, because of enzymatic hydrolysis and all, so that we get a pooled Maillard reaction there. And then this ribose or glycose, from glycolysis again glucose comes, from ATP ribose comes, and then from amino acids, that free amino acid, and we get a pool of amino acids. So that gives you a flavor part of your meat. That place means that as a basic food technology, we know that the carbohydrate and amino acid gives a Maillard reaction. But in this particular thing, that inosine monophosphate, that IMP results of the ATP, that plays a major role in production of meaty aroma. How? I'll just show you that. So the precursors here, desirable flavor, that meat must contain the interact or degrade during cooking to produce a compound responsible for the characteristics flavor of meat. These what we call at the precursors. So IMP is a strong precursor of producing the meaty flavor in a system. So flavor precursors are non-volatile, water-soluble and fat-soluble, and wide range of amino acid, sugars, and nucleotides. That is all are the precursors. Now look at this. The IMP, that study says that these three isomers of the inosine monophosphate is available, but only 5' where the phosphate molecule at the 5 position it is attached, that is the flavor precursors in the meat system, not 2' or 3', that where that at second position the phosphate moiety is attached, and where the third, but only at this particular. So how I can prove it? I'll show you. as a study in the lab, where we have seen that this ribose, and the glycine, like this particular amino acid, when we react it and at a particular temperature, and we get a cooked meaty aroma. Similarly with the thymine. So these particular amino acids are reacted, a combination glycine, lysine, and cysteine reacted with the carbohydrate, and we get a meaty aroma. So now the different flavor due to cooking is a direct function of temperature and degree of moisture available in the system. So this we can study through the GC, MS analysis and all. So just I'll give you example of a few compounds which is isolated through the degradation of the thymine or with the cysteine, lysine in the carbohydrate. So see that the few compounds isolated means the one thiopine, 2-methyl thiopine, or 2-methyl 4. So which is written with the red. They are the meaty aroma compounds, and it is resulted from our thiamine or cysteine thiamine or ribose combination in a vitro study. So if we can control, my objective is that if we can control the protein of the meat, hydrolysis of the protein, or with this ribose, availability of the ribose or glycogen, and when we cook our meat, react with these compounds, we'll get these particular compounds, which gives you a different type of the meaty aroma. So if I just go with the very typical compound, where there is, if you just at the bottom, 2-methyl 3-methyl thiofurone, and this particular compound is a meaty aroma compound, and it has been, means in the lab also we have established that the bottom three compounds, they are highly meaty aroma compound generated in the test tube. So goal is that, okay, we don't get these compounds from the meat, we can synthesize in a very simple reaction way, and then we can use these compounds for the any kind of the product development. This also we have proved in the system. Now similarly way, thiamine also, the same compounds it is generated. Earlier I showed you the compounds which is generated through cysteine, thiamine and ribose combination, and simply here in the thiamine also results into the same, and the meat is rich source of these all the precursors. So these particular compounds which is labeled with the high different color, all they are meaty compound, meaty aroma compounds. So we can generate these compounds in test tube also. We can get a natural flavor from the amino acids or this one. Now these compounds I have tested in the, means in the laboratory, we have tested in the product development also, and which gives you. So okay, let us come to a very most popular product. See, the processing of meat technology. Here the one and the most skillful and a very high-tech product, it is the sausage. Everybody cannot make the sausage. Emulsion, preparation, and then processing, it is a very highly skillful scientific approach. We should know the technique, we should know the additives, the role of each ingredient, and the specific ratio of the ingredients, and the processing the steps, that becomes very important. So the processing of sausage or development of the sausage with the chicken or mutton or fish or any type, that needs a high tech, means you should know the processing, the role of ingredient and scientific approach of these all use of these ingredients, sausage. So that is the one product. So how the types of the so, see in the last bottom tray, you can see a little bit the fracturing, some sausage in the center, which means this is the deep faulty system in your processing. Could be a high level of use of one particular emulsion making ingredient, or the stuffing technique it is wrong, or temperature of cooking is wrong. So many things are there. So this type of the technology needs a very high scientific background for the production of the product. So this is the final product. Similarly, if you just, we have developed a product, instant product, that is a type of the kebab, where we have used the minced meat, the processed dried product, dried dehydrated meat. So it's a instant product. Means just we have a full-fledged develop where the chicken meat, it is added with the binders and your emulsifying agents, and just add water that gives you a cutlet or any type of the product. Your product is ready within a 10 minutes. So this kind of the thing where we found that after dehydration we lose the flavor of the meat. So to overcompensate that, we have fortified it with the particular amino acids, and we get the same flavor what we expect from the fresh meat. So that is the objective, to study the flavor part. How to means retain your flavor. We have not added any synthetic flavor. We have added only original flavor, which generates during your processing, during your cooking or frying of the product. So this is the way how we can control the quality of the product. Is a very innovative product. That poha is very popular in our traditional system. So just to give a nutritional to this poha, rice flakes coated with the meat powder. Again, we face this problem of the flavor. So the same system we applied by using the flavor to control that flavor precursors. We added into this, and we got a very meaty aroma in the system, and of course a high nutritious product. And of course, sensory property, it is just like your meat product. So this poha, it is a coated with the meat powder, it gives a very quality product. Now, similarly, we have developed a products with now in the market, it is there, the chicken wafer, like your potato wafers. So any source of the meat, by incorporating the different type of the techniques, we can develop the wafers like egg, chicken, fish, prawn, or even that sheep or goat or pig, any kind of the source of the meat we can develop. And similarly, the same thing we can apply with your any vegetable source also. We can restructure it and develop the wafers from all these sources. Now, these are the few products which is already there in the market. Now, based on this, now I'm just coming to a daily based need of our meat industry, that what we are looking for, that as a restaurant product, or as a housewife, or a chicken or a restaurant, means a cold chain system, and now looking at the convenience of the market or the trend of the market, and of course that looking at the population type of the products what they want, a varieties of the product which is especially related to the self-stable, because we are lacking with the cold chain system. We don't have a proper cold chain system for marketing of the fresh meat or the frozen meat. Of course, it is in the supermarket, it is available, but the marketing system in our country, it is very from region to region and from area to area. So that's why we need a self-stable meat products. Varieties of the products are prepared, is available in the market, of course, and these are the technologies available. And any type of the product, the especially in the market, it is means the ready to eat type of the product or ready to cook type of product. Everybody wants to eat meat, but nobody wants to cook, because of the laborious nature, because of the non-availability of the ingredient, because of doesn't know how to cook it, and of course they don't have time also. So looking at all these factors, especially with the doesn't know how to cook, number of the ingredients required, the number of the gadgets required, these are the general things which is not available with everybody. So looking at this, we have developed means a varieties of the product which gives the convenience to your meat preparation and all. These are the ready-made pastes available, self-stable for 9 months. So use a particular type of the paste, and then we can have any kind of the non-vegetarian preparation. Your chicken biryani, it will be ready within 7 minutes. Can you imagine? Just 2 tables. You don't need anything to add. So this type of the preparations are there where we can look into this type of the. Similarly, a multi-purpose of the Wonder Mix, that is also again a combination of our traditional ingredients, and it gives a very traditional taste to your profile to your product, which is developed under the hurdle concept: low pH, low moisture content, low water activity, and of course it is a pasteurized, then established, and 9 months shelf life we get. And it is multi-purpose use. You can develop vegetarian dish or non-vegetarian dish or rice or noodles, anywhere we can. Even you can stuff a little bit to your parathas and making all those chapati, you'll get a different taste in there. So we need a different taste in our profile system. That's why we have a different breakfast, we have lunch different, dinner different, because it is a human tendency. And of course, scientifically also it is a very true, because we need a different kind of the nutrients. So that is available through the different source of the food habits. So that's why it is required to, as a food technologist, I look into this aspect also, that we need a different varieties of the food because of our body requirement, as well as of course of our taste profile requirement. With this all, I thank you all the participants, and thanks again, I thank you to the organizers who has given me this opportunity to just share my few ideas about the meat technology. And it is of course, it is a bit neglected sub area in the food processing, I should say that one. So with this, thank you very much. Yes, Dr. Arun, over to you.
Thank you so much, sir.
Yeah, Dr. Rachna.
Yes, sir. How are you, sir?
Fine.
Great to
Great.
see you, sir.
Nice, nice.
Thank you, sir. Thank you for a wonderful presentation. You have covered everything related to meat processing technology. I think we have some questions from our participants.
Yes. Most welcome.
Yes, sir. So there is one question. If you do not stunt during slaughtering, will it affect the taste and quality of the meat? Stunning.
See, if you ask me as a scientific way, yes, definitely it will affect.
Okay.
As a scientifically, definitely it will affect all the factors. As I said, that animal will struggle if you don't stun it, and जिसको हम झटका बोलते हैं, झटके से तो then animal struggles, glycogen content it is lost, and then you don't get a proper pH, so you don't get a proper tenderization in the system. So, and it will affect to the flavor of the meat, it will affect to the tender of the meat. So stunning, it is a very important part of see that stunning may be electronic volt, maybe with the carbon dioxide, or maybe some other method also it is there. That depends upon to animal. And in captive bolt system we use, but nowadays it is banned. Of course, captive bolt system, it is not used in abattoir. Now mostly abattoir they use on means a tunnel where a particular dose of the carbon dioxide is given to the animal and becomes the stunning, or a small volt of the current.
Thank you, sir. I think you answered that question. And there is another question from one of our participants. Can meat be dried in a hot air dryer like fruits and vegetables? If yes, what are the key parameters to be controlled?
Yes, it is a very important thing that you can dry the meat by any method, but the pre-treatments are required. See that pre-treatment, as I said, if you dry the meat by mincing, by cooking and mincing, you will get a proper dehydration. But and of course you can, the rehydration it will be better. But if you dry the chunk as such, the chances of spoilage is very high, because during drying process what happens, the surface dries very fast and it becomes a very hard surface, and that moisture from the inside doesn't come out, and that moisture, meat protein and moisture available in the inside the meat, that becomes a incubation center for the bacteria. So spoilage starts from the inside. So that pre-treatment, it is very, very important in the meat. So size of the meat and the temperature, it is a very important. If you use high temperature like your vegetable and all, the meat becomes very tough. So you have to deal in a very characteristic way while dehydration. So best thing is that texturized it, that the portion of the meat by reduction in the size of the particle, and then dry at a in such a way that your quality of the products are not affected.
Thank you, sir. Thank you for the answer. There is one participant. He's willing to ask a question.
Sure.
Can you, Mr. Ganesh?
Good morning, sir.
Yes, good morning.
Good morning, sir. Myself, Ganesh. Currently, I'm working in Sneha Farms Private Limited as a QA and QC senior executive in poultry-based company. So my doubt is, Can we go for thawing method, sir? Which thawing method is better?
See, thawing actually best nowadays, commercially, we use the microwave system. So
Mean
that is a
like,
little quick and safe method. But some restaurants, they use it as a running water system also. Okay.
normal water or chilled water, sir?
Normal water, chilled water, no, we cannot use a chilled water. Normal water, because your meat, it is at -18.
Yeah,
So when
yes,
you
sir.
calculate that
Yes.
water at normal temperature, that water temperature will go at 2 to 4 to 6 degrees centigrade. It becomes already chilled.
But
So
normal water it is not good, sir, because of we are getting much drip loss, na.
what you get?
Normal water is not good method, sir, because of we will get much drip loss. That is problem.
No, I'm not getting exactly what you are telling.
He's saying the quality of running water may be tap water or normal water.
No, that
maybe.
you have to assure. That you have to assure that the potable water only you have to use it. Quality
Yes,
water means that water actually it is a means you should use a potable water only. You cannot use other water.
normal water in the sense the temperature should be normal and it should be a potable
Yeah, see, your frozen meat is
water
at
free from
-18.
contaminations. Yes, sir.
Yeah.
Thank you, sir. There is another question I will ask.
Hello,
Yeah,
sir.
please.
Present
Hello.
Yes,
Hello.
please
Sir.
introduce yourself.
Sir, I'm Siddhartha, sir.
Yes.
We want to start a meat processing unit, small processing unit. What my doubt is, earlier you have answered that regarding the stunning. Will stunning affect the taste and quality of meat? You said scientific way it is yes.
Yes.
I'm talking. I need to, in case of poultry, if I do halal cut, will it is it fine instead of stunning in view of taste and quality of meat?
See, halal, it is okay. No, means again, that means your halal method, it is a recognized method of slaughtering the animal. I
Yes, sir.
don't look at with the it is associated with the religion and all. Scientific way, halal method is, it is perfectly okay for slaughtering the animal.
Okay, sir. Okay, sir. I mean, will it affect any taste in the quality and taste of the meat, poultry meat?
Yes, see, if you just go with the stunning method, that is the one of the best method for getting the quality of meat. But
Yes, sir.
since you don't want to go stunning, then of course that whatever source it is available, you are available with the halal or jhatka, we have to go with that system only.
Okay,
But
okay, sir.
still I say that as a scientific, stunning, it is a very important and it controls the quality of your product.
Okay, sir. And in the antemortem, hello.
Yeah, antemortem, it is very important.
So for
Antemortem and
poultry also, sir.
postmortem both.
For poultry also.
Yes.
Okay.
For
Okay,
poultry
sir.
also.
Okay, okay, sir. Can you suggest any best breed for sheep or goat for meat purpose, sir?
That all depends upon the region wise.
Okay,
See, in
okay.
Karnataka, Banur sheep, as I showed in the picture, that gives you a very tender meat. That your leg portions are, because that the particular muscles, they grow very fast. That is a meat breed.
Okay, sir.
So that it is that is available. That depends upon the type of the breeds available for meat that we should use it.
Thank you, sir. Thank you for your clarification regarding the questions. Abhipriya, you can take over.
Thank you. Thank
hello,
you, Dr.
sir.
Arun. Okay, Dr. Rachna. Nice.
Hello,
Yes,
sir.
sir. Thank you. Thank you so much, sir.
Thank you. Okay, bye-bye.
Bye-bye, sir. Take care, sir.
Okay, thank you very much.
Hello. Thank you, sir, for your nice presentation. Now we are giving a short break of 30 minutes. We'll restart our meeting after 11:30. On 11:30, Dr. Shivani Pathania ma'am will be presenting in her respective lecture. And to prepare consumer food industry in Ireland. He is also a co-editor of one book, authored 18 peer-reviewed publications and 8 book chapters. Thank you, ma'am, for being here. I would like to request you to deliver your lecture about novel packaging techniques for perishable food. Over to you, ma'am.
Thank you, Abhipriya. Thank you very much. So I will share my screen now. So please let me know
Yes,
like
ma'am.
if everything is in order, and then, okay. It does say there are so many. Okay, sorry. Share. Can you see my screen?
Yes, ma'am.
Perfect. Thank you very much. So, hello everyone. My name is Shivani, as Abhipriya has already told you, and I work in Chagas Cashtown. So, this is a Department of Agriculture, Food, Marine research organization in Ireland, and we have 8 different centers, and we do essentially farm to fork research. And we, especially our center, works on prepared consumer foods and cereal technologies, as well as the meat technology. And my research group is still growing, and our group is called a Sustainable Processing and Packaging Research Group, because we work on packaging and processing both. And if you have any questions, you can ask me at the end of the presentation, or alternatively, you can actually ring me on my phone number, or you can email me. If I'm unable to answer your questions, I'll be very happy to address those questions later on. So let's start this presentation. And if you have any questions, do drop your question, do drop it in the chat box, and we can address to them. So let's start the presentation then. So I want to give you the outline of the presentation first, that what is coming for you in the next few minutes of this presentation. So I know that so we have a mix of an audience. So we have students, faculty, and industry people. So this presentation has been drafted in a way that I could address each of my audience. If you want to ask technical questions, you're welcome. And if it does not cater to your experience level, you can also let me know. I can take care of those questions as well. So we will discuss about the food packaging polymers. I would assume that you will have the basic knowledge of food packaging, but if not, this presentation is going to give you a bit of an idea of what packaging is and what different polymers do and what different food categories can be packaged using different food polymers. Then we'll talk about the current scenario of the packaging worldwide, as well as in Europe and India. I will also discuss about the novel technologies, which is the topic of this presentation. I will take you through the next generation packaging solutions that are coming on board. So you might have seen them, you might not have seen them. So they would be coming in the market in coming years, or probably they have already come into the market. So it's up to you, like how much market research or how much observations you have made in the market while you're shopping as a consumer. The next is introduction to our group research that we do. Now, we do a lot of confidential research projects, so we aren't allowed to discuss that, but then I would give you hints of the work that we have done. And if there are any questions, we can take care of them as well. And at the end, we'll have a discussion. I hope it would be an open discussion, and we can have a fair knowledge transfer between each other. So let's go next. So what are some facts? I want to let you know, like where the packaging stands at the moment. So there I think most of us, or probably all of us, know that there are two categories of plastics. We have thermosets and we have thermoplastics. They have their very own properties and they have their own applications. Now, in order to meet the applications, you must understand what is your product requirement. And it's not only your product requirement, you also need to understand what's the life of your product. What does your consumer want? You will see that recently the word sustainability, new packaging is coming up, a lot. Why so? Because your consumer is interested in those attributes of your packaging material. So that would mean that it will actually divert your research and your how do you say, energy into that direction, because at the end of the day you have to meet your consumers' demand, and you will also have to help the global economy to grow. So this understanding of plastics is important at the start to help your team and your group to identify the correct solution for your product. Now, it's not only food product I'm talking about here. It could be any kind of food product, any kind of product, I'm sorry. Now, we have 7 typical packaging polymers. So I'll take you through what those polymers are. Packaging can be a daunting science, but we'll discuss the basics of it so that you feel that, yes, at the end of the presentation, you're more comfortable with the topic. So what this little triangle that you see on the right-hand side, which is one with the numbers from 1 to 7, and then we have others as well. These numbers, you will see them like globally. It is legal. It is legally required for you to actually have this stamp on your packaging material. You have to tell your consumer, you have to tell your retailer what packaging material you're using. Now, these numbers would suggest if a packaging is recyclable or not, or if a packaging is compostable. So, for example, if you're using a PET, which is a very good recyclable material. So by recyclable, I mean so your bottle of Coke, for example, or your bottle of Pepsi, if you drink Pepsi and you put it in the bin, and if it goes to the right sources, it will actually be used as a recyclate to make another materials. So recyclability these days is very important. Then you have HDPE, again, it's high density polyethylene. It is also recyclable. We have polyvinyl chloride. We have PVC, which is no more food contact material approved. So we stay away from it as food businesses. We have low density polyethylene, which is used as you would see it in bottles, and you would also see it as film. So it's very interesting material. You have polypropylene, insanely used in food industry, has lovely properties. It is flexible, it's versatile. So that's why it is being used. So next time, if you look at your packaging, I'd say either you are going to see number 5 or you're going to see number 1. And that would mean that your packaging, you're actually contributing towards circular economy concept, which is that if a material has come into existence, it will keep rotating within the system as long as it's possible. Then you have number 6, your number 7, and then you have others. Now you will see that the number of others is actually growing tremendously. Why? Because your consumer is interested in biodegradable plastics. By saying it, every plastic is biodegradable, but it is the nature of the degradation that decides if a material is compostable or non-compostable. So I will discuss this so that you have a clarity that like if I'm using a word, what that word would mean to you. The next is, now this is the data from 2015. So there was a cumulative production of like 7.8 billion tons of plastic. And we would see that after 2005, I think half of the world's plastic was produced. So you can imagine that the amount of the production that's taking place globally. Now, 146 million tons of it is used in food packaging. So you can imagine where we are heading. So the convenience foods are coming in. Consumer wants security, that their food is good, that it is, and especially during COVID times, everybody wanted that their foods are safe. So, and then we have different categories of food. Now, within those now you would be like, only 21? No. So within the different food categories, you will have different food products, but basically they have been divided into these categories. So let's go to the next slide. So how big is your packaging industry? So if, just a moment. Yeah. So if Google processes around 80,000 searches per second, your packaging is 320,000 products which are packed and emptied every second. So this is an industry which is 4 times larger than Google. This is just to give you a perspective that while I have been giving this presentation, we have no idea how many numbers of packs have been already packaged. Sorry. Now the awareness. So whatever is happening, the novel technologies that are coming up, why are they coming up? Like how did the idea come? It's not only the improvement side of it. It is consumer driven side of it, market driven side of it. So most of the consumers are seeking products that are completely eco-friendly, but there are still many barriers on the design and manufacturing side. That's where the research and development is coming into picture. Then you have how sustainable is the food packaging industry? That's another question that has been raised so many times. And I think at the European and American levels and global levels, this is coming into picture that most of the companies have already started working on sustainable packaging solutions. Then we are a sector which is contributing hugely to the single-use plastic market, single-use plastic. So the idea is to reduce single-use plastic, but plastic is so versatile that you have to do research and development to find out a solution for this product. Like this product can do massive, it has massive applications. You could turn and twist and reuse and recycle. How about the solution that you're bringing to the market? Is it expensive? Can you use it? How can you use it? How many number of times you can use it? So these are the questions that have been raised. So we do not want to be a contributor to the problem that you see in the picture. So that is why another more and more work is required. And recently, many food companies have actually made a pact that they would work on the food packaging solutions and that they would not contribute, or they would contribute less towards wastage problem. So why is packaging necessary? So we know that food packaging has multiple functions to perform, of which product preservation, hygiene, and convenience is paramount. So if your product is not saved from the damage or from spoilage, there's no point of packaging your product. And your packaging also relays a brand image. So for example, if you look at a Coca-Cola bottle, you would identify it's a Coke bottle. You will never say it's a thumbs up. Why? Because it's the packaging and the way it has, it has been marketed to you, or it has been branded to you, that you understand how important that is. And choice of material basically relies on the necessary packaging function. So you have to identify a material that would do what you want it to do. So is packaging justified? Absolutely, it is justified because it can extend the shelf life of an energy-intensive product such as meat, and minimizing the environmental impact and thus waste reduction. So 97% of the carbon footprint basically lies in the food and 3% lies within the packaging. So if you have spent 97% of your energy in actually growing that food, in processing that food, it's worth to spend that 3% to save that food. Because if your food gets lost, or it gets spoiled, then you are losing more energy. So packaging is a support function, and this is how it should be. It should always remain as a support function. We should not do unnecessary packaging to just improve the look of the product, because that's not what it should do in the first place. So what's going on in the packaging front? Like what happened in the recent years? So in 2020, we all saw something different from the rest of our lives, or probably in the generations. It was COVID-19. So what basically happened during COVID-19? How did it affect this sector? So what happened was that your food volume change by segment is given in this slide, and you will look that there's a huge spike in the consumption in 2020. Why did it happen? Because all of us were at homes, all of us were eating food, and all we wanted was to eat safe food. And thanks to the food industry, the way it has been channeled, that none of the global supply chain has been affected. You will see that now, because of because of various reasons, the global logistics have been badly affected. The transportation has become so expensive, and then you are not getting the products in time. So if you would go to stores, I don't know how the situation is in India, but in here, you would see that the stores are getting empty. They haven't received their deliveries, it's getting late. But the crucial point to understand here is that basically the laws that were made over a period of time, they took into account that something unlikely like COVID-19 can happen. And none of the countries in the world have seen food scarcity. That is because the packaging function, that's because the packaging was there, the food was supplied everywhere just as it was before. So that's why food safety gave a confidence to the consumer that they are safe. So you can imagine how important food packaging is. Now you will see in the slide that there's a huge spike in the consumption of bread and cereal products, and then COVID, but there was a reduction in baby food and pet food. Why did it happen? Because mostly people were at home and they were cooking for their pets and their babies, and then that's why they were not having enough. There wasn't enough demand, but otherwise there was. But what does this mean? Like, why am I discussing this here? It's not out of question, but because every food packaging, every food product essentially is perishable. It just depends. It's a matter of time when it is going to get spoiled. So I want to bring to your attention that all the food products that we have discussed or we have processed are actually going to get spoiled. And every food category has some of the products which are highly perishable or which would be relatively, we use the word non-perishable, and yes, we can. So which are non-perishable. So the likes of pasta, they were bought a lot because they gave a safety that yes, they will not go bad. That the flours, the pulses, their sales had spiked as well. So what does this mean? I'm coming to the point that the packaging demand has also increased. So you will see that it is a comparison between 2019 and 2026. I couldn't find the global figures, so I have the Europe figures. So the demand for all the packaging has increased. So where does our group's research come into picture? So we work on flexible films. We work on bags. We do research on trays, and we do research on clamshells as well. So as the packaging has spiked, its demand has spiked, its research and development needs have also gone up. So we have seen that yes, more and more companies are coming to us to find a solution to reduce the plastic or to increase the safety functions of the packaging. So in the rest of the slides, that's what I'm going to discuss with you. So what are the different packaging technologies that we have on board in Chagask or in my group? That these are the technologies that we work on. So the first is the cartons and the pouches. So we don't work exactly in cartons and bottles, but we do have collaborations with the companies or with the research organizations who does that. But we do pouches. So you see those Verka milk pouches. We have those machines, and we can do research around that area. We also do tray sealing. So I will show you what tray sealing is and how does it work. So we do a lot of work on tray sealing, different trays, different films, and how you can increase the shelf life of the food, not only the raw food, but the processed food as well. We also do form sealing. We can have different types of bags. We'll discuss this. We do can seaming and thermoforming. So I will also tell you the difference between tray sealing and thermoforming and how it can contribute towards food safety as well as reduction in the plastic waste. So how do we tackle the challenge? So the challenge of waste and the challenge of reducing the waste and increasing the shelf life, we also have to take into account that our packaging has to meet these 6 different attributes. So the first is if you can reuse your packaging, if it is recyclable, either mechanical or chemical. Is your packaging compostable? Is it a responsible use, or are you using any recycled material? So recycled word means that if your packaging, if your virgin plastic material has been used once, you recycle it and it is food contact material approved, and you use it again in the packaging. So recycled use is going up and up, and we have to see its effect on the perishability, on the shelf life of the products. And then we have edible packaging solutions. And we must understand, to meet all these challenges, there is no one correct answer. It has to be a blend of solutions, or it has to be, you'll need to have an open approach towards it. the different polymers that you could use during this time. So the production of bioplastics is actually expected to grow by 20% by 2022. And so as it does, the consumer understanding of bioplastics will also need to grow. So we have these. So if you look on the upper left-hand side, these are the bioplastics, which are non-biodegradable. You have to understand, if something is bio-based, it does not have to be biodegradable or compostable. You can actually have polymers which are non-biodegradable or relatively as biodegradable as fossil-based plastic. So and there are some bioplastics which are biodegradable and recyclable. So I'll bring you to the next slide so that we have a better understanding. So if you were to ask me what my preference would be, so it would be a bio-based recyclable material because it's derived from the nature, renewable sources, and it is recyclable. So it will stay in the system for a longer period of time, which is what we want. The second would be a fossil-based recyclable material. Because again, if a material is made, if it has come into the system, it will stay within the system. And then the bio-based compostable materials, you could use them. Yes, they have wonderful solutions, but they also have to meet, research and development is required to meet the solutions that the recyclable material is providing them. To clarify what compostable is, I think by the definition, whenever it should disintegrate within 12 weeks of time, it should biodegrade at least 90% in 6 months. Now, disintegration and biodegradability are different words. Please take into account. The standards are known as ASTM 6400 or EN 13432. You don't have to remember it. It's all right. And then at the end, we should have at least 10%, like we have 10% left over, which is composed, which is free of toxins, and which is used to actually grow other food. So that's what compostable means. I hope it brings a clarity to this word. I would like to bring this to your attention, the Eurobarometer results. They were very interesting because we saw that in Europe, especially, the SMEs and the large companies were working on waste minimization. So SMEs, we will see that yes, SMEs have less resources, and that is why large companies would do that. So overall, when we looked at the figures in Europe, that's exactly what was happening. But when we came to Ireland, it was very interesting that the new companies that are coming up in Ireland are actually minimizing waste, and the number is 84%. It's very interesting because it means that they are aware that this is what is needed. And then they're working on green packaging solutions, secondary shelf life extension, reducing single-use plastics, and they are also promoting the design and production of plastics and plastic products. Now, I will come to the shelf life part of this presentation. If we double the shelf life of a product, food waste is reduced by 40%. Do we really understand like what this sentence means? It's huge, because if a product currently has 7 days of shelf life, it has to go out of the shelf on the 7th day. But if your product is actually safe for 14 days, it is going to stay in the shelf for longer, will have more chances of being sold, more chances of being consumed, and more chances that it will not be wasted. So in India, I think the figures are very, very much better as compared to any other country because we do not waste food. We are such a good example for some of the products, although we do not manage our waste, which is questionable, but we do. We have very low waste production in terms of consumer-led waste. I'm not saying the processing or post-harvest. I might raise some questions here, but I do think that consumer-led losses are very less in India. So to bring to your perspective that why product design is relatively higher in one area rather than the other, this is the answer to your question. It is the price per unit of the product that drives research and innovation as well. If you will look into this in this graph, your fish and your seafood is very highly priced. If it is very highly priced, and if it is hard to grow, and if it is an energy intensive product, you would want to save it. Now your meat losses are so less, but if you look at the figures that the percentage of the percentage amount that's been lost is 30%. So you lose very less of a product, but when you look at the value is very higher. So that is why you would see that most of the solutions, packaging solutions, are coming into this sector first, because you got to save the product. So most of the discussion that I'm going to have will be around fish, chicken, seafood. And as you will see, these solutions will be slowly absorbed by other sectors. They will change the properties of the packaging material, and slowly each sector will have those solutions. So that's what I wanted to say through this slide. Now the product design. It's very important. So the novel packaging technology that Multivac and DC Smith, Multivac is a huge packaging packaging machine manufacturer. They have actually developed this bowl. It's an eco bowl. I'm actually giving you an example. I'm giving you examples so that you understand where the research and development is progressing. In this case, we can never think of packaging a meat in paper, can you? But this is what it is. So it is not only a storage container for meat or for chicken. It also does modified atmospheric packaging. So the very first presentation of this whole series of webinars that you are listening to, I think my colleague, the first colleague, had actually did give presentation on active packaging. That is why I'm not discussing it a lot, because he has already covered the subject wonderfully. And then so this is a paper-based packaging. It's recyclable. You can store meat in it. You can store any product, and it will give you a shelf life exactly similar to a fossil packaging-based material. The next is your flow pack. So you would see usually in around globally, I think, this mince is sold in trays. So this was a very smart solution by Sudpack, which it's a polypropylene based material. And what it does is so the material flows, and it is protecting your product. It is giving you the shelf life, and you're using less than 60% of the material, and it weighs only 9.5 grams. So you can imagine like what novelty they're bringing on board. These are the solutions for the yogurt pots. So they have reduced the amount of packaging material they would use. So I think they had reduced around 16% plastic, and it is called down gauging. Down gauging is that if you're using a thicker material, you'll use a thinner material which will have the same properties, or which will at least not affect the properties that were demonstrated by the thicker material. And it is 100% recyclable. This is a very interesting solution. So when you do recycling, recycling is a mechanical process. It's not manual. It is in some countries it is semi-manual, and in some countries it's completely machine-based solution. So if your product is actually flowing through the cameras, the product is segregated, for example. So it's segregated. But the black trays were not segregated because the camera couldn't see the black color. It couldn't identify. So basically, all the packaging was actually going to the waste. So this was a very smart solution called as Detector. So they changed the material inherently. And what happened was that the packaging can now be very easily identified by the cameras. So Tesco's is a huge retailer in Ireland and in UK. They have used this, and they have saved thousands of kilos of the packaging from going to the landfill. So it was a very smart solution. Now packaging designs. What is the novel technology that's coming on board? Can you believe digital printing in itself has changed the way the shelf life we were getting on some products? So for example, if you do high density digital printing, your consumer doesn't need to see the product from the eye in the front. Do you know what I mean? Like you limit the light. So this is an example. So this is Lando Frost product. You cannot see the product in this particular package, but if you reverse it, you can see it. You can see the product. But what it does is it limits the light exposure. So it is inhibiting your light-induced lipid oxidation. So it's enhancing the shelf life. So it's not only the packaging function, it's the printing, it's how it is being stored in the retail market, how you're storing it at home that affects the shelf life. So the companies are actually working on farm to fork solutions. So that's why you will see that this is a very smart solution, and they have actually won an award for this smart solution that they have come up with. Of the shelf life extension measures, I know in India, if we think of perishable, the first thing that comes to our mind is, I think, milk. And then the second would be fruits and vegetables. We don't think of other products as perishables for some reason. So I try to include every product that is perishable. And you will see that most of the solutions will be observed by other sectors sooner or later. Now, we all know about modified atmospheric packaging. I just wanted to relay the fact that if you use modified atmospheric packaging, which is the air, which is different than atmospheric air, if used in products, will give you a higher shelf life. But you also have to understand that you have to be smart in using your MAP solution. So you cannot use so for example, a 70:30 nitrogen and carbon dioxide is a very good solution for most of the convenience foods, but you cannot use that solution for meat or for fruits and vegetables. So that's where a lot of research comes into picture. So we do provide solutions such as different gas combinations, and we see like if it affects the product properties, if it extends the shelf life of the properties, and we have seen some very good results. Apart from that, now that you're using modified atmospheric packaging, and let's say you achieved 40% of shelf life extension, you use absorbers. So if you use the pads which can actually absorb the moisture, that would mean your moisture lead spoilage will be controlled. So it's not only one solution, I'm so sorry. It is a combination of one or two or three different shelf life enhancing features. And it is a very smart solution that's been provided. I think in food, you'll all know, we talk about hurdle technology. So that's what it is. We are providing hurdles to extend the shelf life of the product. Okay, so I will show you some very simple solutions that's being used in packaging. It's not enhancing shelf life, but it is being, how do you say, accepted by the consumer. So you're using your reusable bags. You will see that your bananas are not sold like this, but it's not. I know it's not in India. It's here. We used to get bananas in polythene bags. Now they've stopped it. So they have started wrapping it in the paper, which is huge. Then in some of the Asian countries, they actually wrap, in India as well, they wrap the product in the leaf itself. What can be better than that if it does not affect the shelf life of the product? Now, I'm actually going to show you the solution that we have for cucumber. It is such a good solution because it does extend the shelf life of cucumber by how many percent? I'd say 40%. So cucumber wrapped in plastic. You'll be like, okay, there's food wastage. No, because it is increasing the shelf life of cucumber by number of days. So a consumer has to understand, or as a food scientist, you have to understand that why you are using certain solution, and why do you have to bring in board? Do you want to lose the cucumber or do you want to protect it? And because if you shrink wrap something, the amount of plastic that's used is very low, very low. So you would get actually if you open the bag of chips, if you eat chips, at the end you're left with some bits and bytes. That's what's left when you use the shrink wrap material. But if you save the product, that's what you want to do. So it is a smart solution that's being used. You can use recyclable materials in egg trays. So that will extend the shelf life, and that will protect the eggs from breakage. And that will also provide safety against the moisture loss, which is important aspect in case of egg product. Consumption reduction is another kind of novel technology that's being used. So instead of using refrigeration systems, for example, bulk refrigeration systems are very energy intensive. So this Apple Sciences is a company, it's Gates Foundation backed company. They have made this plant derived solution that doubles or actually triples the shelf life of many types of fresh produce. So it actually reduces your reliance on refrigeration, on plastic packaging, and controlled atmospheric throughout the supply chain. Then to the left is a seaweed-based edible bubble of water, which was a very smart solution, and I think I had to include it, that you actually buy the bubble and you just have it. So you either you eat it, it's an edible product, or you put it in the compostable bin, or wherever you're going to throw it, it is actually going to dissolve in nature. So it was a very smart solution. Now, extended producer responsibility is that this solution had actually won award in the Packaging Innovation Awards, and I always include it in my presentations because I think it's very important to understand that packaging, it's primary packaging that you see in stores, but the secondary packaging, or the packaging that's been used to transport the product from the farm to the retail center, also contributes to the product safety. So how can you save the product and how can you save the energy? So these smart cartons were developed by them. So they're plastic and they are a blend of material, and they reduce the use of energy. So they have added some fiber to the product, so it reduces the post-harvest losses, which is very important, and it also reduces the use of energy in the cold chain houses, because air travels faster within these systems, so your product does not get spoiled easily. The next is the Adobe Sustainable Design of the Year. I really like this technology. It's called Bee Loop. It's a honey pot. Now it's made of beeswax and organic linen. So it's recyclable, it's renewable, it's edible, it's biodegradable. It is antifungal, antiviral, antiseptic. So it is an active packaging material. It's antibacterial as well, and it's even label-free. How is it label-free? Because they actually stamp the product for their branding. So it was a very smart solution brought by this company. Now I want to show you, now I have series of videos for you to see. These videos will show you how packaging is done. If you have questions, I can address them at the later stage, and I am showing you these presentations to understand how products are being packed. I hope I have assumed that some of you know how it works, and I also made an assumption that most of you would like to know how it works, how the product is packaged. So if you know, I'm sorry, but if you don't know, I hope you enjoy it. So this is a skin packaging solution. So it says skin means your product stays as is and your film wraps around it. So you look at the product as it was. So just look at the product. So it can be used for dairy. It is used for different products. So your film becomes like a second skin on the product. You will see the shape, the size, the color of the product. And because there's vacuum in the product, it extends the shelf life of the product. I'm not sure if such packaging is as prevalent in our home country, but it is very prevalent here, and we do a lot of research in this packaging. So not only what you can do in skin packaging is you can use the absorbing pads beneath, so that whatever the moisture that has been released during skin packaging is absorbed, or during transport or during storage is stored, and then the product does not get spoiled. You basically have to take a scissor at the end and cut the packaging open, but it's a very, very smart solution. Now, the new novelty that has come into this in this side of packaging is that you can use a paper board to protect or to package the different products. So this is one solution. You can see that I have actually highlighted the links from where I have actually edited these videos, so you can have a look at it. The next one is a shrink wrap. So it's again a vacuum packaging. There is a solution. Okay, so what you do is you shrink wrap your product so that there'll be no oxygen, or there'll be no interaction with the outside environment. And what you do is, like, you take these packaging materials and you put them in a secondary high barrier material. So when the product is not in the retail, is not being sold and is being transferred and stored, you store the product in high barrier secondary packaging materials. That way, you extend the shelf life of the product. And once your product goes to the retail counter, what you do is you remove your secondary packaging, and your primary packaging has a WVTR, let's say OTR, your oxygen transmission of like 60,000 cubic centimeters per day. CC meters square per day. That way, the product will immediately absorb oxygen and the color will be bright red instead of brown, which consumer doesn't like. So this is a very smart, novel technology that has come recently. So just have a look at it. So what you do is your product goes into a packaging material. You do the vacuum packaging. It's again the multi-vac machine that I'm showing here. So you cut the packaging material, you do the vacuum processing, you take the machine further, and there will be heat treatment. So you will see that the product is being conveyed to a steaming chamber. Then you dry the product because it's steamed, and that's your product. You're ready to go, and you will have a high barrier secondary packaging material. It could be an integrated process with this machine, or it could be in a different line. Thermoforming. So what you saw in the first video was a tray sealing concept. So you have a tray which is already formed. So you form a stack of trays, and then the tray is being filled with the product, and then that's how it gets packed. Thermoforming is you don't have trays. That saves your money in warehousing, a lot of money in warehousing. You have rolls of thicker materials, and you will see in this slide that those rolls actually gets shaped into a tray. Not exactly a tray, it's a flexible tray, or it could be a harder tray, but it's not as hard as a tray. So it will get shaped into a tray, and then you fill the product into it. Either you fill it manually or you fill it with a robot, and then you seal it. It's called thermoforming. So just have a look. So if you look at it, if you look to the right hand side, it's the roller, and then the second container is where your package is being shaped. It goes further, you load the product, you go further, and you seal the top layer. That's what thermoforming is. It does look simple, but it is not that simple, because you have to find the right material for your product, the right sealant, the properties of the product, the top layer and the bottom layer must match. So what I'm going to bring to your okay, give me a second. I'm actually going to show you how this works, the thermoforming process. I think it's easier if seen. You will remember it for a longer period of time. Here. So if this yellow, let's assume, not assume actually, it is the yellow layer on the top of this mold is your roll, is your film. Look how this is shaped into a container. That's it. So you give the shape and it takes the shape of the tray. You can give any shape. You can wrap your chapatis, or you can wrap your curries in it. You can put rice in it. You can have two, you can have double well, you can have triple well, and then that's how they're shaped. So now I will tell you, like, you can also, this is a thermoformed solution. Next to the thermoformed solution, you saved your plastic here. You can use an active packaging film here. Next is you can actually do high pressure processing. So for high pressure processing, you will need to have a film which has a very strong bond, but then high pressure processing is actually going to increase the shelf life of the product. You just have to make sure that your product does not get, how do you say, it is high pressure processing suitable. That's the important part. So in this particular solution, which has again won an award, is they use ethylene copolymers and ionomers containing sodium and zinc advanced protein adhesion systems, and it reduces residual liquids within the package, which means you'll have an extended shelf life of the product. So it increases the shelf life of the product. Now I'm actually going to introduce you to the group research that we do in Chagask. This video will tell you how we make packaging films from the scratch to get an idea, and then how do we take the process further and we bring the films which are industrially, can be developed industrially. So please have a look. I think we all are aware of this process. It's a very lab-based trial and error method, but then you proceed to it. You take the cues from the research and then you go further. Okay, so you might have made the films, you might use a different process. This is just to give you an idea how we are doing a trial, let's say a single trial. We could use different processes, we can use different temperatures, time temperature combinations. There can be so many permutations and combinations, but this is just to give you an idea that this is where it starts. And then the further is we actually have a twin screw extruder. So what we do is we actually extrude the material and we add we haven't done yet, we can add nanomaterials to it. So we are looking to add nanotubes or nanoparticles into the packaging material and then see if we get any active component or active property out of it. Then we use two film forming machines. So we have a co-extrusion ultra micro blown film and we have a cast film. So whatever you do in the lab has to be taken to a pilot scale so that you know that your product is industrially, can be manufactured industrially. So I will show you like what the idea is. So we took the polylactic acid component and then we tried to make the film from it. Just have a look at the machine. We have 3 single screw extruders which convey the material, so we can make single layer and we can make multi-layer. And this machine is actually going to show you the casting process. So this is how the films are made in industry, but this is a very small, how do you say, prototype of it, but it does tell you that your product is processable. So these are your PLA granules. It's PLA 443. This is where the product melts. Do you see the rolls there? You can see that a clear film is being formed and it's being shaped. And that's where you get your film. So that's your casting method. Industrially, that's how it's been done. Of course, the volume and the size is massive, but this is a tiny little machine that we have, and this is what it does. So that's how you receive the film rolls. The next one is the blow film extrusion. So you can see that not only that we cast, okay. So, and after the films are being produced, we do the package testing. So we test new films. We do different types of tests that are done on packaging material. So we also test the map effectiveness, the transmission properties. We also do the testing and validation for food industries if needed. Now, apart from it, we also have systems which could contribute to the hurdle technology to extend the shelf life of the products, which would be, for example, a UV light system that we have. So this particular UV light system we use for, you can use it for chickens, for example, to extend the shelf life of chicken, or you could use it for your fruits and vegetables, especially mushrooms have been tested on this one. So the capabilities of this system is that it can disinfect any product surfaces. So you can disinfect your packaging material before you're packaging the product. And once the product is packaged, you can actually use this machine to give treatment to the packaged product. So it enhances the shelf life of the product once it's packed, or it can also, contributes towards increasing the shelf life by disinfecting the packaging material. It ensures food safety, it improves shelf life, and there are no chemical residues to it. So it can be applied to various food categories. Then we have cold plasma. I know cold plasma has been discussed a lot yesterday as well. I think some of the audience is very much aware of this technology. I'm myself relatively new to this technology for packaging applications. So if you have any questions, I think I might be a little bit tight in answering those. But yeah, so capabilities in activation of bacteria on food matrices. You can use it to increase the surface area of your packaging material, thereby increasing the active ingredients, property of the product. And it is very energy efficient, and it's cold. It's called cold fire as well. So applications as solid foods, liquids, and packaging films. So we have another project that we are doing is leaf no waste. So we are extending the shelf life and reducing the waste of salad leaves. So what we are doing is we are growing our spinach and mustard leaves so we started on a seed phase. We moved to the concept phase, and now we are competing for a 2 million funding for this one. So I think we are doing very good with this project. So in this project, the idea is to treat your foliar, your leaves with silicone, so that once the product is packaged, it does not lose moisture, because it's the moisture loss in spinach and mustard leaves that reduces the shelf life. So it is a hurdle technology. So we are also testing different packaging materials, and that which packaging material after refrigeration is going to give you the longest shelf life. So I'll show you what it looks like. So you see here, so these are the spinach leaves. We have treated them, and we are testing them in PLA films. So we have a control, and then we did 2 different treatments to the spinach leaves, and we are testing which of the treatment of the 3 is actually performing best in the PLA film. We are also testing the same concept for OPP, which is your oriented polypropylene film. It is used a lot in salad leaves industry because it's very flexible. You use it very less. You can use very thin films for it, like 10 micrometers or something, or 15, 20 maybe. But in case of bioplastics, you'll have to use thicker films because they are not as easily formable as OPP. Then your third one is your cellulose film. So not only that we are testing different treatments, we are also testing different packaging materials to see which one's working the best. And we are also testing that post-refrigeration, which one performs the best. So it's not that once you have sold it, it's not your responsibility. We are working from farm to fork solutions around it. So this is the work that we have been doing. So the final words for the presentation would be that you must understand the shelf life of the product and what is causing the spoilage to find out the right solution. There are solutions out there, but you must understand your product. The type of packaging, for example, recyclable or compostable, must be guided by the product requirement. Keep up to date with the legislations and regulations, very important. And food businesses can consult an expert to understand necessary packaging functions and the right packaging machines before investing. So that's it. Sustainability takes the chair, and we must respect sustainability. So thank you very much for your attention. I have been talking for an hour. I can't believe it. So this session is now open for discussion. Thank you.
Thank you. Excellent presentation.
Thank you.
We have some questions from our audience.
No problem at all. I cannot. Can you see my screen? I'm sorry.
Yeah, ma'am. Your screen is-
I am trying to stop share. I can't see it. Can you do it for me, please?
One you have to- Yeah.
Thank you. Yes, please. Go ahead.
Audience, those who have any clarification, please raise your hand.
Sorry?
There is a question from our audience. I'll ask
Yeah.
them to talk to you directly.
I can't really hear you.
Good
Dr.
morning, ma'am.
Yes, I can. Yes, please.
Yeah, good morning, ma'am. This is Saptashish. I'm from IIT Delhi, a research scholar. So, ma'am, actually, nowadays there is hello, ma'am.
Yes,
Am I
I
audible?
can hear you.
Yeah.
Yes, you're audible.
Actually, ma'am, nowadays there is scary news all over the media that most people are exposed to toxic plastic like BPA or like permanent plastic every day. And though these pollutants are common and in our household items like plastic, water, and packaging things, though they are present in very such low doses that there's a harm to our human life, I mean, directly or like instantly. But scientists are now started reporting that these chemicals even they are found in breast milk, and as you know that breastfeeding is still the healthiest food source for babies. So my ma'am, I just want to know that as you are working too much work in this particular field, is it really scary, or what is your opinion, ma'am? Like, is it our really future generation as I mean in the threat of for such kind of any things like?
Okay, so thank you very much for your question, Saptashish. Very well observed. And I do work in packaging area, but I think it would be how do I call it? I'm not being diplomatic here, but this is not my area of research. My area of research is to down gauge or to provide activity. But you're right, there are some reports that yes, we have microplastics coming into human food chain via oceans. That the plastic that's being released into the oceans is actually being eaten by fishes, and then it's already in the food chain. We already have microplastics in our blood. It's being tested. It's not my area of research, but I definitely know that this is being researched on, and it is a matter of concern. And that most of the food packaging companies, that is why I think they are doing the research and development to get away from it. So if there are new compostable solutions coming into the point is that the packaging material that has been developed from years are being researched on toxicity, for toxicity. But the new materials that are being developed are only tested for functionality, but not toxicity. Do you know what I mean? So I think the whole industry has to work together so that there is no concerns of any human toxicity in nature, that the product is, let's say, not harmful for for human health. We must work on it, but I personally haven't done any toxicity work myself, but I know it's a matter of concern. I'm so sorry I couldn't address this better, because I know very less about this side of the field. Is that okay?
Yes, ma'am. I will ask and next participant to ask question. Srisha, please
Good morning,
introduce
ma'am.
yourself.
Yeah. Good afternoon, ma'am. I am MTech student in food technology from Jain University.
Hi, Shweta.
Yes, ma'am. Actually, I wanted to know that bioplastics are also a new trend these days. Can it be used for packaging long shelved, like to provide foods a long shelf life?
Yes, is that your question? Like, can I answer it, or do you want to ask something else as well with it?
Yes, ma'am. Yes,
Okay.
ma'am. That is my question.
So yes, definitely you can use it. Bioplastics. The issue with the bioplastics at the moment is they are not as functional as a fossil-based polymer is. So we are talking about microns here. So if thickness is not a problem for the manufacturer or for the retailer, then definitely they can provide shelf life. They are as functional as in terms of activity, or providing shelf life. They can be as good as fossil-based polymers, and you will find solutions around the globe wherein they provide similar, or rather a bit higher as well in some cases. If it is actively packed and if it has secondary barriers, it will provide you a shelf life as comparable to the fossil polymers.
Thank you, ma'am.
Okay, okay. Thank you, ma'am.
No problem. Thank you.
There is some questions in chat box as well.
Yes, I do see question and answers from Siddhartha and Charul as well. Is it different from the chat questions?
No, ma'am, it's same.
Okay, I can take these questions, Arun. It's okay. So from Siddhartha, I have a question that the UV light system for chicken and vegetables, will it affect the nutritional value or texture or taste? Thank you for the question. UV light system, it's a newer technology. It's getting very popular. You wouldn't believe, but in Singapore, I think the milk is also UV treated. So UV treatment is known to be, it's cold treatment, and it's known to be very effective. It has germicidal effects. In terms of nutritional value, if you're talking about the significant and non-significant results. So for different food products, if we have to go into the research side of things, yes, it could to an extent, but I don't think so that effects could be negated by the extension of shelf life that you're going to get out of it. And then the texture or taste, your taste could go, in case of chicken, you can have some light oxidation, but I think it's the amount of the time that your product is being treated for. So if your treatment time is low, I don't think so there will be any effect. Rather, it is going to extend the shelf life, but not affect your texture or taste. I hope that answers your questions, Data. Is it? I'm not sure why I'm asking if it answers your question, but I'll just move on. Oh, thank you so much. Then Charul has asked a question that what is the cost of production of PLA film and for which food products we can use this film? PLA is nearly 4 times expensive than a fossil-based film. And for which food products? There are so many food products that you can pack. So for example, we have sandwich films which are being packed in PLA. PLA has relatively less flexibility. So currently, I think the teams are working on the flexibility and providing it so that it is thermoformable and it is, we can form, fill, and seal it. We are working on those lines. But yes, I think there are many fruits and vegetables which are being stored, which are being packaged in PLA film. I hope that answers your question. Then Suman Manna has a question that if we combine edible packaging material with plastic, what would be the effect of it? Oh, different effects. Again, permutations and combinations. I'm actually going by the words that you're asking me the question. So if you're using an edible packaging material, you wouldn't want to pack it in a plastic because you want an edible packaging to substitute the plastic. But you can also have an additive effect if you're using your edible packaging material with the plastic, but you must find out you must think what your product is and what effect do you want to get out of it. If it is the extension of shelf life, yes, many a times different technologies have been combined together. If it is something else, you'll have to find out. I hope that answers your question.
There is another question from the participant.
Which is
Yes.
packaging is is Sanjeev Pal, yeah?
No, ma'am, we do vacuum packaging of meat. Will it affect the taste and quality of the meat?
That is a very, I think that's the most talked about question globally in the meat industry, because vacuum packaging gives you the best solution in terms of shelf life, but in terms of color, it doesn't give a very good color because of the metmyoglobin content that goes up on that. So in that case, what you do is in most of the retail sectors, what they do is they vacuum pack the product to ship it globally. So from Ireland to China, we ship the product using vacuum packaging. And then at the retail store, if your consumer, there is a fine balance between the two. So your consumer prefers a brighter red meat, but your vacuum packaged meat is as good, cheaper, and is safer. So it does not affect the problem. It affects it sensorically, I'd say, but not chemically in a way. Chemically as well, because metmyoglobin is being formed, but it's safer. It's very, very safer than modified atmospheric packaging or tray sealing or thermoforming. It's very good technology.
Is there any changes in the taste, ma'am?
In the taste, I wouldn't. Yes, there have been some studies, some group focused group studies, and they have found out the people who have been eating a lot of food can identify some differences in the taste. But otherwise, if you're not a regular meat eater, so for example, if you're a flexitarian, you wouldn't pick up the differences.
Thank you, ma'am. Another question from our participant. What will be the suitable packaging technology for fresh mushrooms? And what will be the expected shelf life?
Oh, okay. So we did some work on mushrooms. So what we do is we use a tray, and then we use a cellulose film on the top of it. Sometimes it's cellulose, sometimes it's I think mostly it's cellulose. And what we do is sometimes we treat it with UV in the UV chamber, or we in India, I think it's treated with sodium bicarbonate, which shouldn't be done because when you are giving it a treatment, you are actually hydrating the product, which shouldn't be the case, because if you're hydrating it, you're decreasing the shelf life. So you get around 7 to 10 days of shelf life, if I'm not wrong. You can get higher as well. Yes, but you also have to keep in mind that the temperature conditions in India are different than where I am working. So if I'm saying 7 to 10 days, it might be different for India because the temperatures in India are very high in summers and they're very low in winters. And the product is being sold in a regular market. In retail setting here, the temperature is controlled. So, and the moisture is controlled, the relative humidity is controlled. So if we get that number of days, it is defined by the conditions that we have provided to the product as well. So please take into account that factor as well.
Thank you, ma'am. One of our participants want to interact with you. Tanveer Ahmad.
Yeah, sure.
Tanveer, you can unmute. Oh, he's not here, I think. Ajay Desai. If you have any question, you can directly ask.
I think he's asked a question, no? That in dried fish, which packaging is good in terms of shelf life?
Yes, ma'am.
I haven't worked with dried fish ever. I have worked with seafood, but I have worked with fresh seafood. So we have done thermoforming and we have done skin a bit, but I haven't done dried fish. So I think I wouldn't be able to help you. I've seen dried cod here, but I think the dried cod is skin packaged and just brought here and it's available. It's dried and salted. So that's what I have seen, but I haven't worked in it. So I'm so sorry, I won't be able to help you.
Hello.
Hello.
Hi. Hello, Shivan ma'am.
Yes.
Yeah. Actually, it's good talk regarding what your novel packaging with the perishable foods. Because a little bit myself. This is Dr. Ajay Desai, working as assistant professor in College of Fishery Science, Maharashtra.
Okay.
Yeah, ma'am. Actually, I'm working with the seafood and its nutritional quality. So I would like to ask that whatever you told that you can say in the Ireland side, your working area is different rather than the dried fish. But as such, in the Indian concerns, we have the dried fish, and we are because people, they are generally using the solar train dried and cabinet dried for drying purpose. But as such, there's no technology for the packaging. So we are looking for the any packaging technology for the dried fish, so we can keep the product for the communities, for the our customer, for the longer shelf life. So as you told, as in the cod in the Ireland, where you have just you have packed. So what type of actually package in the Ireland for use in that condition for the dried fish, dried cod?
So the cod that I have seen in the market, and I haven't seen it in Ireland, I have actually seen it in Portugal. So they have dried salted cod outside in the retail store, like not outside, inside the retail store, but it's not packed. But if you want to pack your dried fish, now I'm just throwing it in the air. I haven't seen your product. I don't know the water activity of it. I don't know the texture of it, but I think you could do skin packaging. You could vacuum pack it. What is the moisture content of your product?
Moisture content 5 to 10.
Yeah, maybe. I don't know if there would be some residual moisture. You could use the packs, they absorb the absorbent pads, and maybe you could skin pack it. I think that would give you the best solution, but then you would also have to see if the vacuum has some effect on your product. So this could be the nearest solution that I could say you could use for your product. But if you want, you can actually email me and we can have a conversation about it. Now, whosoever emails me, I'm on leave at the moment, but I will definitely try to come back as soon as possible.
Okay,
I
thank
hope
you.
that address. You're welcome. You're welcome.
Yeah, thank you. Thank you. Wish you a
Thank you.
Thank you, ma'am, for answering the questions patiently.
No problem. I hope we have addressed most of the questions.
Yes, ma'am.
There was, okay. Okay.
Abhipriya?
Perfect.
Thank you,
Is it-
ma'am. It was such nice presentation and for delivering the information about packaging techniques of perishable foods. Here we are finishing our morning session. We will be restarting our meeting again after lunch break by 2 p.m. All the participants are requested to be online. Thank you.
Thank you.
Thank you so much, ma'am.
No problem, Khalid.
See you soon. Thank you. Thank you once again.
Sorry?
Shivani madam, can you put your email, please?
Yes, I can do that.
We'll share it, ma'am.
Oh, okay. I've typed it, Khalid. It's all right. I think can I put it in the chat?
Yeah, ma'am, sure.
Yes,
I
yes,
did that. Yeah.
Thank you, ma'am.
Thank you. Okay, so yeah, can I take your leave now? Like, is
Yes,
that
ma'am.
okay?
Thank you so much, ma'am.
Perfect.
ma'am.
Thanks very much, everyone. And thank you so much. And I didn't say thank you for extending the invitation. I just missed it. So
Thank you,
take
ma'am.
care. Thanks very much. Bye. Bye.